a boost or a step up converter. So this is my circuit of a boost converter. We have a inductor, then we will have a switch which will be replacing with a power BJT, a diode, a capacitor, and a resistor across the load. R will act as a load, and V in we will be applying as a DC supply. Alright, so let us simulate this circuit in eSim. Remember, since it is a step-up converter, my output voltage will be greater than my input voltage. So let's build up the circuit in eSim. So you go to eSim and click on New Project, and kindly name the project as, let us say I will be naming it as Step Up, and make sure that you don't leave any spacing in between. Okay, so I've written over here step up converter. I'll click on OK, and then I will click on create a new schematic or open a new schematic. So it will prompt that it does not, the schematic does not exist, and do you wish to create it? Click on yes. So the moment you click on yes, a new schematic will be created, and over here we will be start building our components. So let us go over here, that is place component, and click over there, and you can click on the screen, and here we will select first of all eSim underscore npn. So this is the BJT which we'll be using to give as a trigger pulse. Now we'll also require a DC source. So again I'll go to place component and click over here and type DC. So here I will select this DC, click on OK, and I'll place this DC source over here. Alright. Okay. Next I'll require an inductor. So I'll again go to place component, click over here, and I'll type eSim underscore L. Yeah. So we have the inductor over here. I'll click on OK, and I'll place the inductor somewhere around here. Alright. Next I will require a diode. So again I'll type eSim underscore diode. Yeah. So the diode has come up. Here I'll place the diode over here. Okay, now we require a resistor and a capacitor, so only two components are remaining. So I'll type eSim underscore C. So this is my capacitor which I will add in across the load in parallel with the load. So here it is, and finally we will add a resistor. So for the resistor I'll click over here, I'll type eSim underscore R. So this is my resistor which eSim is providing in the library. Now I will place this register over here. Now if I want to rotate it, I'll right click over there and I click on orient clockwise. So this has been rotated. Now since all the components have been added, actually there is one more source which is required. We have to give a pulse to this to trigger the BJT, right? So I've already clicked over the place component. I'll click over here and I'll type pulse. So from eSIM sources, we will get pulse, and this I can place it over here. Alright. Now all the components and the sources have been added. Now I have to connect them with a wire. So here is my wire. I can little bit maximize it. Okay, so I'll start connecting them with the wire. So I've connected the inductor to the source, and now I'll be connecting the DC supply to the BJT emitter terminal. Then the inductor, I'll be connecting it to the collector terminal of the BJT. Next, I'll be connecting the collector terminal of BJT to the diode. Then the diode will go to the capacitor, as well as it will go to the, okay, I'll cancel this. It will also go to the resistor, and the resistor and the capacitor other end will go to the ground, like this. So my circuit connections are complete. Also, I will connect this V pulse source over here. All right. Now I have to also make the ground connections. So for the ground connections, I can again go to place component, click over here, and I'll type eSim underscore ground, GND ground. So I'll place one ground over here and another ground over here. Okay. And I'll connect them with a wire. So in this manner, my circuit connections, I have made my step-up converter or a boost chopper. Okay. So the circuit is complete. Now the next thing is to define the values of L. So here I'll right click, sorry, I'll click over here and I'll go over here and I right click, edit value. So edit value I can give it over here as 1.5 millihenry. So I'll just type over here 1.5 milli. It is by default it will take it as around 1.5 millihenry. Now let me go over here once. Okay. I should save this file. So I'll click on save schematic project. Okay, regularly saving the file is advantageous. Now I'll click over this C. Oh, sorry. Okay, click over here and edit value. So here the capacitor value I've taken it as around 100 microfarad. So 100 U you can type. And finally the register. So I'll go over here once, right click, edit reference. So the register value will be around, okay, I'll cancel this because I'll require eSim underscore register that I edit that I have to edit. So here I can give it as around 33 ohms. All right. So I've given all the values of resistors. Now I have to plot certain quantities. So let's say I want to plot my input. All right. So for plotting the input, I'll place the global label first. So I click over here and then on the screen. One second. Okay. Let me go back over here, refresh it. Okay. So I did global properties. I'll show it again. So I'll go over here, click on edit global properties. So here I'll give it as input in, orientation will be right, shape is input. So I'll place it over here. All right. Then I'll connect this with a wire. Okay. So this has labeled the input as in. Then I want to plot this value. So what I will do, I'll go again to the place component, click over here, and I'll type plot V1. Plot, I'll select plot V1. So this plot V1 will plot the value of input. Will plot input actually. Okay, I'll connect it with a wire like this. All right. Then what else I have to plot? I have to plot my let's say the input pulse here, right? So I'll click over here. Okay. First of all, I should add the label. I'll call it as a pulse. That is input again. So I'll keep the orientation same, and I'll add it the pulse over here. Then I'll connect it with a wire. Okay, it is connected. Now I'll add the plot V1. I'll connect it over here, let's say, and then join it with a wire. Okay, so this it will plot V pulse. Next, I want to plot the output. So for the output, I'll place the global label over here. I'll keep it as output and I'll write it as OUT, out, and I'll place the global label over here. Okay, orientation I can select it as, let me go to the edit global label. Orientation will be left so that I can keep it outside. Let me drag it over here. Yeah, so now I'll connect it with a wire. So I've labeled the output node as out, and now I will be plotting it also. So I will, okay, click on place component and add plot V1. Okay, so plot V1 is added. So this will plot my output voltage. I'll connect it over here at the output. Okay. Now I also want to plot the output current. So what I will do, output current is to be plotted in series. So I'll right click over here, delete the wire. All right. Then I have to go to place component and click over here and I'll type plot. I'll maximize the eSim plot and there I'll select plot I2. So this will plot the current through a branch. So I'll connect it back with the wire, the diode over here, and finally like this. All right. So yeah. So these are the stuff I want to plot. I want to plot input, V pulse, output current, and output voltage. So this is my step up converter or a boost chopper. All right. So after I've connected the circuit, I'll click on Save Schematic Project. Then I'll go to Netlist, click on Spice, click on Default, check on Default Format, and click on Generate. It will generate the netlist. Now save the netlist. It will ask to annotate. So please annotate, click on Annotate, and click on OK. Okay. So as you can see, the circuit is annotated. Earlier it was L question mark, D question mark, C question mark, and now it has been definite numbers being provided over here. All right. So since the circuit schematic is generated now, again I'll go to save schematic project and now I minimize. Now I have to give the component the analysis type, select the analysis type and give the values. Now I'll go over here and right click, click on refresh. Now I click on convert keycad to Ngspice. Here I will define the select the analysis type as transient and enter the transient parameters. So start time will be 0. Step time I can keep it as around 100 microseconds. So I'll type over here 100 and I'll select microseconds from here. And then stop time I will select it as around 24 milliseconds. Alright. Now the source details will be V1 is my voltage of the DC source. So that I'll give it as around 6 volt. Then the pulse source for the BJT, here I'll give it as initial value as 0, final value as 6. Then the delay time will be 0. Then rise time will be 1 nanoseconds. Fall time will be 1 nanoseconds. Pulse width I want to give it as around 5 microseconds. And then the period will be around 10 microseconds. So if the pulse width is actually T on time and period is around capital T, so T on upon T is around 5 micro divided by 10 micro, that will be 0.5. So that means my duty cycle I'm setting it over here as 0.5 or 50% duty cycle. Alright. Next I'll go to Ngspice. We have nothing. Here we have device modeling. So here I'll click on add. See, we have to add NPN transistor. So click on add and here I'll select on transistor. From here I'll select NPN and click on open. So the library is getting added, got added. Now we have to add a library for the diode. So click on add, click on the diode and select D and click on open. Okay. So in this way we will add the library for the diode and the NPN transistor. Now all the things we have entered. Now we click on convert. So keycad to Ngspice conversion is complete. We'll click on OK, and we'll go over here and again press refresh. So as you can see, all the library files and cir.out file is added over here. Now I'll go to simulate and click on the simulate button. Hopefully it should simulate and give us the correct output in the first go. Okay, so it's giving the values. Let us analyze it quickly. All right, so let us check the output value. Okay, so from here we have already seen that the formula which is relating the input and output voltage is given as follows. It's V out upon V in is 1 upon 1 minus D. So in our case, duty cycle is 50%, that is zero point 0.5. So 1 upon zero point 0.5, that will be twice. And V in value is 6. In our case, V in value is 6. So V out should be close to 12. Let's see if it is close to 12. Yeah, this is the transient part. Up till around 12 milliseconds, you get the transient part. And after 12 to 24 milliseconds, you are getting a steady state part. So if I want to maximize this part over here, I'll right click on my mouse and I'll select a small section over here, which will give me the expanded view of that section. I'll right click and expand, and again I'll select a smaller section and expand. So as you can see, this is my output ripple value, right? It's varying between 11.18 to 11.16 value. All right. So it should be 12 ideally, but it's close to 12. So that's fine because over here we are using a normal BJT. In fact, if we use a power BJT, in our analysis, we have used a normal BJT, NPN BJT. If we use a power BJT, then definitely yes, you will get close to 12 volts DC. So this is also accepted. All right. Now I will close this. Now mostly when you click on this plots, we have to take a print screen and attach as a print, right? So black screen is not required. So what we will do is we will turn the screens into white and make this a little thick. So this is the pulse plot. As you can see, if I expand it further, let's say I have a small section of it like this. So it will be visible. It's compressed because its frequency is high. So as here you can see, these are the pulses. All right. I'll close this. This is my input, which is 6 volt. All right. I'll close everything. Now I want to change the color, right? So I'll right click on I'll double click on the cir.out file, .out file, and go over here. So before the plot, I'll type some statements. So I'll write set color 0 equal to white. Then I'll type set color 1 uh, equal to black. And then I'll type set color 0 to blue. Color 2 to blue. Then afterwards, I'll also set X brush width equal to 3. So this will make the plots a little bit thicker. So I'll click on OK, save and exit, and I'll right click over here, refresh it, and then I'll close the previous Ngspice plots, and now I'll run it again. So mostly I should positively get a plot with a white screen and a blue, yeah, as you can see. So this will be better while taking the printout. This will give you a better look, much better than the black one. So this is my Vout. As you can see, it's moving closer to 12 volts. And that's my output current. And output current is almost constant. And that is what is desired. Alright. Now if I observe the output over here. So as you can see, after 12 it's becoming steady state. So here I'll cut a small section with a right click. Okay, so here is my output ripple. Okay, so in this way, you can simulate a boost converter. And next, what you can do is, let me close this Ngspice plots. I'll close this. Next, I can do is what? I can change the duty cycle. Let's say if I change this duty cycle to this pulse width to 4 microsecond. So what does that mean? This means a 40% duty cycle, meaning D is zero point 0.4. So as per the formula, if D is zero point 0.4, I will get, if V in value is 6 volt, V out will be around 10 volt. Okay, so you can check it out. I will again simulate. I have changed the value. I'll click on convert Ngspice keycad to Ngspice, and then I'll right click. So what should I get at the output? Output voltage close to 10 volt. All right. Okay. We have not set the color, so it's coming. That's why it's coming black screen and green plots. Yeah. So that's what I wanted to highlight. Here the output value is close to 10. Ideally it should be 10, but it's coming nearby 10. That's absolutely fine. So in this way, you will complete the analysis of simulate the boost converter. All right. Okay. So yeah. So here we have to give credit to eSim. eSim is an open source EDA tool for circuit simulation, design and analysis and PCB design. It is integrated with various open source software such as keycad, Ngspice, GHDL, very later MakerChip, and now the new edition Skywater 130. So this team is developed by eSim team at FOSSEE at IIT Bombay, right? So I'll encourage everyone to use eSim for circuit simulation and analysis. Yeah. So yeah, thank you for this video.